All right, today we're going to talk about solving radical equations in inequalities. Section 8.8. Okay. Again, talking about solving radical equations in inequalities. And again, radical, who remembers what a radical stands for? Radical is nothing more than a what? Square root. Square root. So we're solving square root equations essentially today. Here's kind of an example of what this looks like. To solve radical equations, you solve them by raising both sides of the equation to the power of the index of the radical. So what that means here is I have this problem right here. I have the square root of x. What is the opposite of a square root? A squared term. So what do they do to both sides? They square both sides. When I square a square root, that cancels it out, leaving me with then x equals 9, because 3 squared is 9. Alright, so what we're working on today is basically getting rid of the square roots in order to solve for x. Now this next one's a little bit tougher, because there's more to it than just square root. It's 3 square root of x minus 2 equals 18. You want to first get the square root alone. So what do? They divide both sides by 3. When I divide both sides by 3, now I have the square root of x minus 2 equals 6. Okay, getting the square root alone is the first step to these problems. Once I have the square root alone, then I need to undo the square root. What's the opposite of a square root? A squared term. Nice job. So now I square both sides. That undoes the square root, giving me x minus 2 equals 36, and my final answer of x equals 38, because then you'd add the 2 over. Yep. Alright, so that's what we're going to be working on today, is getting rid of the square roots. So the first problem here, number 1. Solve each equation. Okay. So number 1 is 4 cube root of 2x plus 11 equals 12. Notice, what was the first thing we did is we divided by 4, so we get the cube root alone. That is the key steps to these. You have to get the square root or the cube root, so the roots or the radicals alone first. Now, what do you notice? It was a cube root. So now they didn't square both sides, they cubed both sides. Everybody see that? They took both sides to the third power. So taking both sides to the third power now that undoes my cube here, leave me with 2x plus 11 equals 3 to the third, Jesse? 27. So I have 2x plus 11 equals 27. Next, I'm going to do what to get the x alone then? It's just a two-step equation. What do I want to do, Nick? Subtract 11. Giving me 2x equals 16. 3 to the third. And then I divide by 2. And I get x equals 8 as my answer. Alright. Let's look at number 2 here. It's 5 plus the square root of x minus 3 equals 9. Yes, sir.
So when you divide by 4 and stuff, you leave like the 2x plus 11 alone?
Yep. Number 2. Recognize they subtracted 5 on both sides first. Why do we subtract 5? Because we need to get the radical alone. So subtracting 5 leaves me with the square root of x minus 3 equals 4. So I have the square root of x minus 3 equals 4. What undoes a square root? I need to take a squared term to both sides now. So I square both sides, getting me x minus 3 equals 16. 4 squared is 16. Now I need to solve for x. I do what to both sides here, Kelly? So I add 3. And I get x equals 19. Alright, so number 3 here. I have 2. Square root of x plus 4 equals 10. First thing I need to do is get the radical alone. In order to get the radical alone, what do I need to do to both sides? Divide by 2. That gives me the square root of x plus 4 equals 5. Now I need to undo the square root by doing what to both sides? I need to take the Square to both sides. That gives me x plus 4 equals 25. Now I need to get x alone, so what do I do to both sides? I subtract 4. And I get x equals 21. How are we doing so far?
Well,
Good. Because the next thing we're going to talk about is kind of the same, really. They have something that's called, you can have rational exponents. Okay, a rational exponent is just like a radical. For instance, if you see here, this has the 1/2 power. The 1/2 power is the same thing as saying like the square root of x plus 20. Okay, that, let me erase that there. Let's go this way. This right here is the same thing as the square root of x plus 20. A 1/2 power is the same thing as a square root.
it's like a 1/4 power.
Then that would be the same thing as a 4th root. Okay, good question. So what do you notice here? To get rid of the 1/2 power, we take the squared term to both sides. And again, why the squared term? Because the squared term and the 1/2 power then cancel out, giving me x squared equals x plus 20. Anytime I have a quadratic, and I'm talking about solving, I always want to set it equal to what? Set it equal to 0. Nice job. Again, anytime I have a quadratic, I always want to set it equal to 0. Because when I set it equal to 0, now I can solve it by factoring our quadratic formula or whatever we need. So for instance, we factored this one here. I get x plus 4 and x minus 5 equals 0. So my zeros are negative 4 and 5. Notice though, okay, notice when I plug them back in, I can get what's called an extraneous solution. Extraneous solutions means, yes, you solve for it, but it works. But if you plug it back in, it does not check out. So for instance, like when I plugged in negative 4, the square or the 16 to the 1/2 power is not negative 4. 5 is the only one that checks out there. Okay, so make sure you plug it back in when you're given multiple solutions like that to check to see if both of them do actually work in fact. Okay. So number 4 here, I have 5x plus 6 to the 1/4 power equals 3. Notice, they took 4 to both sides. All right, it took both sides to the 4th power. Yes, ma'am.
So when you take, it's not like how this is 1 over 4, but you take 4 each time, like the bottom of the.
Yes, pretty much.
Okay, makes sense.
So those cancel out, giving me 5x plus 6 equals 3 to the 4th power is what, anybody? 81.
Yep.
And now I solve for x. So I'm going to subtract 6. Getting 5x equals 75. Divide by 5. And I end up with x equals 75 divided by 5 is what, Tiana? 15. Nice job. Let's look at number 5 here. 6x minus 8 to the 1/3 power equals 4. I have the 1/3 power. So what do I want to take to both sides to get rid of the 1/3 exponent? I need to take a, what did you say? A 3 to both sides. So I take a 3 to both sides, cancels that out, giving me 6x minus 8 equals 4 to the 3rd. Anybody? 4 to the 3rd? What? 64. So 6x minus 8 equals 64. I'm going to add 8. I get 6x equals 72. Divide by 6. And I come out with x equals... What do you got? 17 divided by 6. 12. Thank you, Mr. Schultz. X equals 12. All right, 6. This is the one that's probably going to be the toughest. You will have like 1 or 2 of these on your assignment, so pay attention here.
Wait, do you have like a, does anyone have like that little pen thing that I can use? My fingers are cracking up over here. No?
Stretch them out, stretch them out.
Oh, okay.
All right, so number 6. X equals parentheses, x plus 6 to the 1/2 power. What do I need to take to both sides? I need to square both sides, right? So we square them. My exponents cancel, giving me x squared equals x plus 6. I have a quadratic. Anytime I have a quadratic, I want to set equal to 0. So I get x squared, x squared minus x minus 6 equals 0. Now that I set it equal to 0, I can solve it by factoring. Two numbers that multiply to get -6, add to get -1. What are those two numbers going to be, Jack? -3 and 2. Nice job. So I get x minus 3 and x plus 2 equals 0. So that means my answers are x equals what? 3 and -2. Now again, I have multiple solutions, so let's make sure we plug them back in. If I plug 3 in, 3 plus 6 is 9. The square root of 9 is 3. That one checks out. I plug -2 in. -2 plus 6 is 4. The square root of 4 is? Oh, did I get -2? So, oops. X equals 3 is technically the only one here that checks out. Okay, and that's part of this. Again, you will have one of the problems on your assignment today, just like number 6 there. Take a couple seconds to try these 4. Try these 4. All right, number 7. The square root of x plus 2 equals 5. Isabel, what did you do to both sides first? Squared both sides. Cancels. I get x plus 2 equals 25. What does x come out to be, Izzy? X equals 23. Nice job. Number 8. What undoes a half rational exponent? What do you need to do? Square. Cancels. I get 4x equals 36. X equals what, Pat? 9. What about number 9? It's an inequality. Treat it the exact same way. What undoes a square root? A squared. So I square both sides. 3x plus 1 is greater than or equal to 64, which means x comes out to be what, Schultz? Nice job, sir. And then number 10. Recognize it's a 1/3 power. What undoes a 1/3 power, Pat? I go by 3. So I get x plus 1 equals 27. X equals 26 then. All right, good work. Here is your assignment.